Hey everyone, welcome back. Continuing our discussion on Java concurrency, in this video we will learn daemon and non-daemon threads. So do check out the previous videos in the same playlist in case you feel lost. Let's get started. So let me ask you a question. What is the life cycle of a process? It can be very complicated if we talk about what happens under the hood. But on a very high level, what does a process do? We start a process, then it does its job, and after that, when there is nothing else to do, it terminates. That's what a process does. In the same way, when we start a Java program, we know it will start a new instance of JVM which will run the code that we have written, and JVM itself runs as a process on the operating system. So how does the JVM know that it has to terminate the execution, that it has done everything that it was asked for? So that's what we are going to see in this video. Let's see in action. So here we have a simple class, Daemon Threads. It has a main method, and in this main method we have a simple log message. In the last video where we covered the common thread methods, we learned what is the purpose of current thread method. It will print the currently executing thread, the name of currently executing thread. And we also know when we run the Java program, JVM will start a main thread by default, which will execute the code written in the main method. So if we run this code, it will be executed by the main thread. So we will see the name main, and you see in the logs, we see main is running and probably finished. And if you notice, as soon as we ran the program, it was very quick to print the log message on the console, and then it terminated. You see this icon, the program is stopped now. Now, what happens if we comment this one and introduce a delay? Because not every program will be as quick as dumping some message on the console. It may take some time. So let's say there is a delay of 3 seconds. We also covered the sleep method in the last video, so do check out if you haven't done so. And with this delay, if we run the program now, notice the program is still running. It's not stopped. And after approximately 3 seconds, when it is out of this sleep, that's when the program stopped. So it waited for approximately 3 seconds. That's the delay that we introduced using sleep method, because sleep method will put the main thread into the sleep state. So what happened in this case, because of this delay of 3 seconds, JVM knows there is a thread which is sleeping, but that thread is alive. So it cannot be stopped and it cannot terminate its execution. So JVM will keep running, and the process was running. And after approximately 3 seconds, when the main thread was out of sleep, it has nothing else to do. So that thread concluded, and now JVM knows there is nothing else running. So it can initiate the shutdown sequence. And that's when JVM will stop its processing and the program will terminate. All right. Now let's move on. And instead of sleep, let's create a new thread. So from the main thread, we'll create a new thread, and we know main thread will also run, and it will create a separate thread that will continue its own execution. So there will be 2 threads at time t, main thread and the new thread that we are going to create. So we'll create a platform thread, we'll give it a name, user thread, and we'll pass it a runnable. Now in this thread, we will introduce a delay of, let's say, 2 seconds. And after 2 seconds, this thread will print something so that we know that this thread is now complete. And then in the main method, we will print another log message, main exiting. All right, let me increase the delay to 5 seconds so that we get a chance to notice what is happening. Let's rerun the program. And we see main exiting immediately, but it is now waiting for another thread because there is a delay of 5 seconds. And approximately after 5 seconds, when this user thread completes the execution, then only the program was stopped. So that means JVM in this case is waiting for another threads, new threads that we created. So it will wait for all these threads to complete their execution, because all the thread will continue the execution in parallel. So in this case, it is not only waiting for main thread, but also for this thread as well, basically the user thread that we created. And after only 5 seconds, when this thread was complete, JVM stopped. So that we already know, as long as there is something running, JVM will not stop. The program will keep running, nothing new. Now let's introduce a new thread. And this time we will create a daemon thread. How do we create a daemon thread? Well, we can use the same builder. We'll give it a name, daemon thread. And how do we create a daemon thread? There is a method in the builder which we can use to define or to create a daemon thread. So we'll pass it true that yes, this is going to be a daemon thread. And then we will pass it a runnable because daemon thread will do something. And this time we will keep the same implementation. That means daemon thread will also do something. So there will be a delay of 5 seconds. And then it will print that this is complete now. And in the same way, let me reduce the delay of this one. So what will happen now? When we run the program, there will be 3 threads. One is the default main thread. Then the main thread will create one non-daemon thread, which is user thread, and the second daemon thread with the name daemon thread. Now this thread will sleep for 2 seconds and then it will print that, hey, I'm complete. And similarly, daemon thread will sleep for 5 seconds, and after 5 seconds, when it's complete, it will dump the message that I'm also complete. And then we have this log message for the main thread. Now the thing is, all these threads will try to execute in parallel concurrently. So let's run the program and notice the behavior of JVM. So we see main exiting. Then we see user thread is complete now, but the program finished. We don't see anything from the daemon thread. Ideally, we would expect this log message coming from the daemon thread that daemon thread is also complete, but this is not the case here. We only see 2 log messages, main exiting and user thread is complete now, and after that JVM terminates. The process is finished. So what is happening here? Why don't we see the message from the daemon thread? So that is the definition and the difference between daemon thread and non-daemon thread. Daemon threads are background threads. They are used to run the background programs. Now that is the difference between daemon and non-daemon threads. Here it is. First of all, any thread that we create is by default non-daemon or user thread. We have to create or mark the threads daemon threads explicitly by either setting the property setDaemon true or using the daemon method of the builder, as we did. So you have to create a daemon thread explicitly, otherwise it will always be a user thread. Now daemon threads are generally low priority threads. They are used to perform the background tasks such as garbage collection or some other cleanup. And because these are low priority tasks, low priority threads, so what JVM does, when JVM initiates the shutdown sequence, it does not wait for the daemon threads. JVM only waits for the user threads or non-daemon threads before it can shut down. So as long as there is any user thread which is still running, JVM will not initiate the shutdown sequence. That's why program will keep running. But as soon as all the user threads have finished the execution, it will not wait for daemon threads because these are background tasks or low priority threads. So in that case, when there is no user thread remaining, JVM will start the shutdown sequence and the program will terminate. And that's what we saw in the demo. So the shutdown sequence begins when all started non-daemon threads have terminated. So all in all, daemon threads will never prevent the shutdown process of JVM. It's always the user threads. And so in this case, because user thread was only sleeping for 2 seconds, so it was out of sleep before the daemon thread, because daemon thread has a sleep time of 5 seconds. So it did its job and then JVM was free to shut down. And that's why it did not wait for daemon thread. Daemon thread was still sleeping, but JVM initiated the shutdown sequence and so the program was terminated without waiting for daemon threads. So that is the difference between daemon and non-daemon threads. Now, talking about the best practices, we need to make sure that we always use daemon threads only for background tasks. Because as we talked about, these are low priority background threads. And we also need to make sure that we don't have long running daemon threads. So that means do not put anything business critical in the daemon threads. If we put anything business critical in the daemon threads, then it can cause serious harms, because as we know, JVM will not stop for daemon threads. So that can make the application inconsistent. So always make sure that we don't put anything critical in the daemon threads. And that brings the third point, that make sure non-daemon threads terminate. Because we know JVM will always wait for non-daemon threads to complete their execution. So what happens when a user thread is blocked or hung? In that case, it will stop JVM from being terminated, and so the whole process will be hung. That's why we need to make sure that all the user threads terminate either abruptly or normally, so that the process can shut down. So that's pretty much it on the daemon and non-daemon threads. I will see you in the next video. Thanks for watching.